All right, welcome to our conclusion of, hey, that's my graph. So today we're going to be figuring out how to use this knowledge. So we've gone through what's the y-intercept mean, and we killed it. We asked ourselves, what's the slope mean? We said it's the rate of growth for our plant that is growing, which is honestly weird because this is a massive plant. And now we're going to figure out, well, how do we use this? So let's say we came in and we said, all right, what is the mass? So we have a question of, what is the mass of this plant after 1 day? All right, so just a heads up, I think we're going to have an Audrey 2 thing going on here. So after 1 day, so we're saying, well, we have an equation that relates mass and time, and we know the growth rate, but here's the thing. First step, if we look at all of our units, this is why it's so important to include units in your equations. This growth rate is for kilograms per second squared. So we're going to have to change 1 day into seconds. So 1 day has 24 hours, and then multiply 24 hours by 60 minutes in an hour times day. 60 minutes in 1 hour times 60 seconds in 1 minute. So this tells us that our actual time that we're going to have to use in our equation up here is not 1 day. So if you put 1 in this equation, you would get not the right answer. So we got 24 times 60, which equals, I'm sure you did this in your heads, 86400 seconds. So 86,400 seconds. All right, so we're going to figure out how big this thing is. So first we got to make sure our units match. So now we're going to put this all up here. So we're looking for mass. And the growth rate for our plants, I'm just going to simplify this to be 4.1 kilograms per second squared. And then I've got my time, which was 86,400 seconds. I'm going to square that. Remember, I'm not including my y-intercept because we deemed that it was illogical, so it should be removed. So now it's a matter of just doing the math. So we'll go through all the steps just to be super clear. So I'd have mass equals 4.1 kilograms per second squared times 86,400 squared times seconds squared. So if we look, including the units in this shows what our answers are going to be. So seconds squared will cancel out seconds squared. If we had left this as days, we would have had days squared over here, and then you should have realized, wait, that doesn't cancel out. I got to change the math. So now we'll be left with units of kilograms, and all we got to do is 4.1 times, I'll square this first, so 86,400 squared first. I'm sure this will be a really small number. Yeah, it's let's just say huge. It's huge. Then we're going to multiply that by 4.1, and we get yeah, you know, a huge value. Just I'm going to write it down just for funsies. So we got mass equals, it's a 3, a 0, a 6, a 0, a 6, a 3, a 3, a 6, and 1, 2, 3. Okay, all right. So this is like and units of kilograms. So let's see, that's the thousands, the millions, the okay. So this is a 30 billion kilogram plant, which I'm sure would take over the world in a day. So yeah, this is scary, but that would be the answer. Okay, this is the downside of just making up data and just saying let's go with it and see where it takes us. But that's how you would actually go about solving these problems. And then, in all honesty, if this was a real problem, be like, this doesn't make sense. I should double check my data. And you know, you might want to double check your data. Maybe you messed up. Maybe instead of in seconds, your unit should have been decade or a year or millennium. I don't know. But this would be the appropriate steps to go through to actually calculate and use the equation that you derived using your data to then, you know, predict the future and see how it's going to take you somewhere. and that is a monstrous blend. Serious Audrey 2 problem. It'd be like an Audrey 20 problem. All right. So thank you for staying with us for Hey, That's My Graph, and join us next time we explore other ideas of physics.